Hello everyone, myself Ankit Chauhan, your physics teacher. What we had done last time? We had completed motion in straight line. Kinematics part we had finished. Now today we are going to go through the conceptual questions based on what we had studied till now. So let's go ahead with very first question. Distance traveled by a freely falling body is proportional to. So freely falling body means acceleration due to gravity will be g, that is constant. If I'll use this relation, equation number 2, so I can see if body is dropped from certain height, then s is proportional to square of time period. So if it is in the options, let's see. Mass, no, it does not depend on mass. Square of acceleration, no. Time of fall, let's see. Square of time of fall. I think this is the answer, as we can see. So body when falls freely, when body is dropped from certain height, u is 0. So uniformly accelerated motion, same I had applied, s is equal to ut plus half at square. If u is 0, that means, because we know that half and g both are constant, so h is proportional to square of time period. The answer is D. Okay guys. The numerical ratio of displacement to distance. As we had seen earlier, the ratio s and x is always lesser than or equal to 1, because displacement, value of displacement is always lesser than or equal to distance. So tell me, when the displacement distance will be same, they will be same when body travels in only one direction. If it reverse the direction or it moves in opposite direction, then it changes. Means they are not equal. Okay, so let's take one example if you would understand. Suppose from O a body moves to 5 meter. So displacement is 5 and distance is also 5. Let's say from O to A it returned back to B, which is 2 meters from this position. Okay, so this was 5 and again it was 2 means it has moved to opposite direction. By how much meter? 2 meter. So we can say 5 meter like this, 2 meter like this. So distance become 5 plus 2, that is 7, while displacement will be initial to final, that is only 3. So till body was moving in same direction, distance displacement both are same. When it changes the direction, distance displacement become different. Always greater than 1, no. Always equal to 1, no. Maybe less than or equal to 1. So answer is 4. Okay, same explanation. The magnitude of displacement distance are equal only when body travels in straight line without change in direction. I just now explained you with example 2. In all other cases, distance is greater than displacement. Next, if the velocity of body does not change with time, its acceleration will be 0, unity, infinity, or may take any finite value. Let's see. Acceleration is equal to change velocity upon time. Means we can write v2 minus v1, okay, or delta v upon delta t. If velocity of body does not change, means delta v is 0. So acceleration is 0. So answer is, as velocity of body does not changes, delta v is 0. So acceleration is 0. The acceleration of moving body can be found from, okay, so acceleration we can take, we can find from the slope of vt graph. Okay, slope of vt graph. Vt graph slope, basically tan of theta, gives us change in velocity upon time, that is acceleration. So here it's very important that slope of vt graph gives us acceleration. Okay, we had already seen this, no need to worry. So answer is in V versus T graph the slope of graph? Answer is 3. Now let's move ahead. Velocity time graph of uniformly accelerated motion. If body is uniformly accelerated, guys, then its acceleration means slope must be same. So it must be always a straight line. Because a graph, which a curved graph represents different angle at different position. Tangent made on this curve shows different angle, means different acceleration. As we know that VT graph, slope of VT graphs gives an acceleration. So answer must be straight line. Okay. So it must be straight line. So answer is yes, V equal to U plus AT. So relation, you can see it is linear relation. So it will should be in the form of straight line. A gun is aimed at a monkey. If monkey falls under gravity at the instant of firing the gun, the bullet will be. Okay. So let's see what will happen. Hope you understood the question. Question says that gun is aimed at monkey. Suppose here is a monkey. Okay. Now gun is aimed at this position, and when it is fired, suddenly this monkey fell down. Monkey fell down under gravity. Same time, we know that this when this bullet is released, same G is acting over this bullet too. So what will happen? Yes, it hits the monkey. Why it hits the monkey? As it moves downward, same time it is moving downward, so it will hit it. How? Let's see. Okay, we have seen this. This will move in project parabolic path and this will fall down. Both will travel same this vertical distance in same time. The two bodies A and B projected horizontally from the top of tower with different velocity at the same instant. The path of B as seen from A. Okay, so both are projected horizontally like this. Okay, with different velocities. So what is the answer? Let's see. What happens? Say the velocity is VA and this velocity is VB. Now guys, what happened? Let's see. Both on both the bodies, acceleration will act G. So the horizontal velocities will be different, but vertical velocity will be same. So as they are projected at same instant, what happened? Let's see. Suppose this is a building. One is projected and other is projected simultaneously. Okay. Speed is VA and VB. What will happen? This instant VA is moving, at the same instant VB is moving. Both will be at same height every time. So relative to A B or relative to B A, both will be appearing as they are in straight line. Okay, because their vertical level from ground will be same. Which of the following has a finite acceleration? Okay, after getting these questions, you might have means you understood this. Why I had written conceptual? Because these are totally based on concept that you had learned earlier. Means in these questions, the numerical part is very less. Okay, go ahead. Which of the following has finite acceleration with zero velocity? Okay, finite acceleration zero velocity. We can say example that when body reaches to the highest point, freely falling body at maximum height, yes. Vertically projected up body, finite acceleration with zero velocity. Actually, it should be the whole answer must be vertically projected body at maximum height. I should write like this. Okay. Okay. Vertically projected, not freely falling. It should be vertically projected body at maximum height. When body reaches at highest point, velocity becomes 0 but acceleration is same. G. If the displacement time graph of body is parallel to time axis. Okay guys, so displacement time graph is parallel to x-axis. This means that the slope is 0, and as we know that slope gives us velocity, that is 0. So velocity of body is 0. Wrong here students, this one by mistake. The answer is 0. Okay, velocity of body is 0, confirm 0, no doubt on that. By mistake, a ball is dropped from certain height. It is an example of uniform velocity. Okay, when it is dropped from certain height, what happens? It is basically an accelerated motion. Okay, and what type of accelerated motion? Uniform or non-uniform? Uniformly accelerated motion. Okay, guys. So let's move ahead. Uniformly accelerated, uniform retardation. So answer is uniformly accelerated motion. Dropped from certain height. It's wrong. Uniformly accelerated motion. So many mistakes done while body projected vertically upward. Here the in question body is not projected vertically upward. It is dropped from certain height. So answer is C, not this one. If body is projected vertically upward, then answer is uniform retardation. Uniform retardation. Okay. When body is projected upward. So I think by mistake question was changed. Means option of question was changed. There are two questions like this. Three bodies ABC thrown from the top of tower at same speed. A is thrown straight up, B is thrown straight down, and C is thrown horizontally. So what they had done, A is thrown straight up, B is thrown straight down, and C is thrown horizontally. All are having same velocity. So what will happen? Let's see. When they hit the ground, relation we had already studied. That relation was, tell me. Okay, first thing, both will reach the ground with same velocity. Okay. Okay, guys, I can explain you the same question with one more way. Let's see. Uh, for this A part, A body, there are three bodies A, B, C, as they had told us. For body A, what is the equation when it reaches to ground? Let's see. Body is projected upward with velocity V. So let's see, and it reaches with velocity VA on the ground. The net displacement is h. When body is projected, acceleration will be taken as minus g. Displacement will be taken as minus h because body when projected upward, the net displacement is downward as we had seen earlier. So when I'll apply the equation v square is equal to u square plus 2gh, sorry 2as. So the velocity when it reaches the ground, va square is equal to v square plus 2, acceleration is minus g and height is minus h. So we get v square plus 2gh. If I take under root, so it will be this one. Now same thing happens with body thrown downward. Now what happened here? Velocity is negative, but since here it is square, so the same answer will come because when body is projected downward, say for this one, we'll take the initial velocity as negative. Okay, so for that again minus v square become v square, so we'll get same answer. And the last but not least, let's go for the next part. Suppose when body is projected horizontally with velocity this v, say v. So guys, you must have noticed that when body is released from certain height, its initial velocity along y direction will be taken as 0. Okay. So v square is equal to u square plus 2gh. Velocity along y axis will be taken as 0. So v is equal to under root 2gh.